Well, good evening and welcome to Space Oddities. Thank you for joining us on this Tuesday evening. Hope you're all well and looking forward to another packed show of fun with the universe. I'm joined by some familiar faces here, and I'm joined by Michael. So, hi, Michael.
Hi there.
Michael's very proud of himself because he managed to use AI to create the image in the background there.
Yep.
And very nice too, Michael. Very nice too.
Thank you.
Roger, all well?
So far.
That's what we're on to hear. How are you, Daz?
I'm fine, thank you very much. We're looking forward to it and raring to go.
Good, that's the spirit. And of course, last but very much not least, Lou. How are you, Lou?
I'm doing well. I used my telescope to make that image in the background.
Oh, wow.
Well, is that one of yours? That's really nice.
Yeah.
Gosh. How's the observatory going?
Oh, it's swimming. Just got my ASI Air, so I'm learning how to use that, and I'll be sending in images, no doubt, soon, to populate our users gallery.
Give him Roger a run for his money.
Yes.
That's my goal.
I'll block them then.
The gauntlet is thrown down.
High bar, you said, Roger.
Okay, well, obviously, we hope you have much value viewers are well too, and I'm just having a look in the chat, see who we've got in tonight. Astronebula, Jerry, hi. Chris, hi. Who else have we got? Gerard, hi. How are you? We've got somebody called Michael, who's no idea who he is.
Interloper.
Good evening. Hope you're well, and thank you for joining us. And well, we've got a bit of a packed program tonight, so I think without further ado, we will move on to Roger. So take it away, Roger.
Okie dokie. Here we go then. So here we go for the first full week of October, and we've got away from the last supermoon of the year, thank God. So yay! So we're waning down now to the last quarter, over towards the end of the start of the weekend. And fortunately, this morning there was a clear sky, so I've got this picture of a setting moon.
That's beautiful.
Lovely.
Beautiful.
And then a few hours later, I caught this.
Nice.
That's lovely.
And a little bit of activity there too around
around the periphery.
Around the periphery.
Yeah.
And
I say.
Oh,
some interesting activity there with a couple of the groups which I've labelled.
right.
I'm not actually on the surface. I've put a label on. That's a label.
They don't signpost these things.
No, they don't signpost
No.
them. No.
They don't.
Anyway. So, as we've now getting through October, we've starting to get the Andromeda in the night sky, Andromeda Galaxy, which will be up very high later in the night sky and through parts of October. So, best opportunity to get the Andromeda Galaxy if we want to do that. And obviously, we've also got Jupiter, which is dominating the night sky as well. And of course, we'll be seeing its opposition next month. So Saturn is still up, but it is starting to go past now into the southwest. But that's still good to go. We're all right for that. But also at just before dawn, we've got the brilliantly vibrant morning star of Venus. And just above the horizon is Mercury, but it will be slowly breaking away from Venus and setting as the week progresses.
Yeah, I saw Venus this morning.
So, and that's in Leo. So that's pretty good. And of course, while that's shining away, we've obviously got Orion up in the night or in the morning sky as well. So, but we've got some interesting James Webb from Orion, and he's what they call these named jumbos, Jupiter mass binary objects.
Yeah, this was very strange. So this is right in the middle of the Orion Nebula, which, as you may know, is a stellar nursery about 1,600 light years from the Earth. It's you can even see it with your naked eye if you look below Orion's belt in a clear sky. You can see the stars that make up the sword of Orion, but you'll see a fuzzy patch there as well, which is the Great Orion Nebula. Now, interestingly, these objects, they're about the mass of Jupiter, and they are not orbiting stars. They're what we call rogue. Well, they would be rogue planets if we were sure that they're planets, but we're not even sure about that. But bizarrely, then these are in pairs. They're binary objects. They're co-orbiting each other. And they found 40 of them so far in the Orion Nebula, which is a hell of a number. And nobody knows what these are. They think that because they're not orbiting stars, they've obviously been ejected from stellar systems. But, scientists are saying, how can there be that many? And exactly where have they come from? So this is a major discovery by the James Webb Space Telescope, which of course we are fairly used to with the JWST of making major discoveries. But these objects are bizarre. And as I said, they're about the mass of Jupiter. That's why they're called Jupiter mass binary objects, or jumbos. And for once, that's a good acronym. What are they? Where did they come from? And why are they in pairs? So Lou, did you have any thoughts about that? Any ideas about that? Because it's most bizarre.
Yeah, well, a couple. You were talking about whether they're planets or stars. If they're Jupiter mass, they're almost certainly not stars. Jupiter's about 1%, something like that, of the mass it would need to turn on. Also, I would be looking forward to a spectrum of these objects to see their black body curve, right? Their Planck curve, to see where that peaks. And from that peak frequency or wavelength, you can derive very straightforwardly a temperature, a surface temperature, and that would say something up also. I think, you guys correct me if I'm wrong, but I think binary objects and binary stars are not that, stars at least, are not that rare.
No, they're not.
We know of many asteroids in our own vicinity that are either binary or have moons. You take your pick. So I don't know. It's very interesting.
Yeah. It's it's another case of who ordered that, isn't it? Just when you think you're beginning to understand things, the web says, no, you don't understand anything. So anyway, that's a really interesting discovery. We will follow up on this, especially as if Lou says they managed to get spectra from these objects.
I do have some other images of the James Webb of around Orion. If you would allow me to.
Yeah, absolutely.
We've got this one, which we've got in a short wavelength, and then we've got this one in a longer wavelength.
Yeah, they're the block.
I've got a close up of the red regions there.
Yes.
It's almost
wow,
and they're
almost like stalagmites, aren't they?
Oh yeah.
These are thought to be the remnants of a collision of two massive stars about, I think if I remember rightly, about 1,000 years ago. And you will notice that the very tips of these objects are green, which is indication of gaseous iron. That's what that is. Well, what can you say? Beautiful image. Really evocative.
Yeah. And the image just before that, they're planetary disks.
Yes.
So they're the gas and the dust surrounding new stars, and they'll be making their own solar systems very soon.
So would the actual stars that are almost in the center of this image, would that be the trapezium?
I think there was something about they didn't notice the trapeze. I don't think that these are.
No, I don't think so.
It's very near to that area, because if I move on, it gives you an area where the James Webb was taking these images.
Yeah. Oh, it could be. It's difficult to know without
Yeah.
without knowing what magnification it's using
Yeah.
there.
But it must be in that region somewhere to get these anomalies.
Somewhere in there.
North.
Derek says, would the Jumbos have formed a new solar system if there'd been a more dominant mass to make a star? Well, possibly, Derek. But, at the moment, we don't even know what they are, really. So we can't really say what would have happened. But we will try and keep you up to date with that story because it's most intriguing. And these objects have never, as far as I know, have never been seen in any other nebulae, only the Orion nebula.
As regards the trapezium, I'm thinking the trapezium's a bit further up, isn't it? It's just above there.
Is it?
It's that little group of stars that are above that block. I think the trapezium is just a little bit up. So
yeah, possibly. Anyway,
possibly we'll see. Yeah.
In regards to Derek's question, remember it's not just mass; it's density.
Yes.
Right? You can have an awful lot of mass, but if it's spread out, or perhaps there's enough energy from the collision or other forces that kind of drive things apart, then the outcome is very different than if you just have a very quiescent mass very close together.
Absolutely. But it just seems so strange that they've discovered 40 of these binary pairs. That's a lot. So presumably they all had a common origin. So, we will keep you posted on that one. Okay, onwards and upwards, Roger.
Onwards and upwards. Okay, so to the members gallery. And we do have a few images this week. We do have a few people who have put in 2 images. But I won't hold that against them.
You better not.
Would that be you? My God.
Not only me, but a few others like Daz. Here we are, a moody harvest moon with his Samsung 22 Ultra.
Wow.
Straight out the camera, and here we are.
Wow.
Oh, that's nice.
That's really nice.
Yeah, I like the way the trees were silhouetted. I mean, that looks quite dramatic, especially with the clouds as well.
Oh yes.
And then you've got the halo as well. Yeah.
Yeah.
What you can do with a camera, on the phone.
Exactly.
Absolutely.
And here we are with a harvest moon on Jupiter, also with the same setup.
Oh, nice. Oh, well done.
Sorry?
Who was that one from?
That was
That's from me. That's from me again. Yeah.
Another one from you.
Yeah.
I love that one as well.
We just had some break in the clouds, and I thought, oh, there's Jupiter. Let's see if we can get that in. So, but you can see the rooftops of the houses and all. I could have trimmed it down a little bit, but
is that your shed at the bottom?
Sorry?
Is that your shed at the bottom there?
I wish.
There's a very big
Our shed's falling down.
That's lovely. That's really nice.
Yeah.
Thank you.
Well done, Daz.
Right. And another regular commentary from Jerry DeLay of the Andromeda Galaxy.
Oh,
here we go. Ta-da.
Oh, wow.
No.
That is amazing.
Yeah,
It's
fantastic.
Well done, Jerry.
Lots of dust lane details there, Jerry.
Yeah.
Very good.
Like 100 hours of integration? What? Oh, my goodness.
100 hours.
Does he say?
It was 50 times 3 minutes. So 5, 3, 50.
150 minutes. So nearly 3 hours.
Yeah, 2.5 hours.
Yeah.
Wow.
That's amazing.
That is amazing. Well done, Jerry.
Both the satellite galaxies there as well.
Oh, yes.
Yeah.
Lovely jubbly.
And one from Sonia of the Harvest
Hi, Sonia.
Moon, with her 10-inch Dob and a Google Pixel 7. So another camera phone image.
Yeah. Oh, that's nice.
Oh, wow.
Isn't it?
That's very nice for a camera phone image. That's really terrific.
With a 10-inch Dob.
Yeah.
Oh, I mean, right, but still.
But even then.
But it's still a wonderful image.
Still very good. And we've got another one from Sonia. And we've got a moon, Jupiter and Saturn this time.
Whoa.
Oh,
wow.
Very nice.
A montage.
Yeah, you see the space between the rings and Saturn and Jupiter's belts.
Very nice. Very nice, Sonia.
Very good.
Yep, very good. Very good.
All right. Oh,
Oh no!
Right. Well, I was having a moan to myself like I do due to the lack of skies from Spartford. I was getting really depressed. So I was going through my billions of pictures and I came through this one. And this one was only taken about 6 months after I first got my camera. And I must have got some jolly good seeing because this is what Jupiter looked like.
Oh.
Oh, please. How do I compete with that? Come on, Roger.
There we are. The gauntlet
Very
is
good.
thrown down low.
Wow.
Yeah.
That's really nice.
It's not bad. It's not bad.
Fantastic.
Yeah, I don't think I've had a good an image of Jupiter since that time, 4.5 years ago, you know. This is only 6 months after I started my trip into astronomy. So
Well done, Roger.
I was
Yep.
more than happy with that.
I'm sure.
And I thought, as winter is coming, I thought
Oh, dear.
Oh, the
share
crab.
a picture of the Crab Nebula.
Yeah.
Nice.
Oh, very nice.
Mm-hmm.
Mm-hmm.
Very nice.
There you
That
are.
actually looks quite wintry, doesn't it?
Mm,
Yeah.
right. Ooh.
Lovely.
Okay, so that
that it?
concludes the gallery as well.
Right. Well, as ever, viewers, if you would like to send us your astronomical images, which we love looking at and love including in the gallery, then please send them to, as ever, spaceodditieslive@gmail.com. That's spaceodditieslive@gmail.com. And, we'll include them in the gallery. And we're still thinking of doing another calendar this year with your images on. And this year we might even manage to get the dates on the calendar. So anyway, we're going to do that. So, who knows, your image might be included in the 2024 Space Oddities calendar. My goodness me, 2024. Anyway, just something that I wanted to mention. We would like a few more on the Space Oddities panel because we are getting a little thin on the ground on a regular basis. So if you would like to become part of Space Oddities and join the panel, I'll tell you what we're looking for. We are looking for somebody who obviously has a good, broad knowledge of astronomy and things like that, and hopefully space exploration as well. Just a general broad knowledge. If you have a specialist area of knowledge, then fantastic, because that would be great to have another specialist. What the job would entail really would be obviously being on the panel, but also creating material for these Tuesday shows, creating presentations. So, good PowerPoint skills. And sorry, I can't remember. What's the Apple equivalent of PowerPoint? It's called...
Apple
whatever
Core.
the Apple equivalent of
Oh,
PowerPoint.
you mean
Apple Core?
No.
No.
It's,
Oh,
Pip?
God.
Is it called Pip?
Oh, God, I've used it so
What's
many
it?
times. I must be
No,
getting
no,
old. My brain is going. Must be tired.
I
That's
know
my
what it
excuse.
is as well.
Whatever the Apple equivalent of PowerPoint is.
Pages? Is it Pages?
No, it's not
No.
Pages. It's the other one.
No. Somebody will tell us in the
Yeah,
chat.
it doesn't matter.
Hang on.
It doesn't matter. It doesn't matter. It doesn't matter what software you use, as long as you can create presentations that can be exported as a PowerPoint, because we can only really handle PowerPoints with this software. So that's it. So if you'd like to become a member of the Space Oddities panel, we will welcome you with fairly open arms. And then we will, if you send us an email, that is to say, spaceodditieslive@gmail.com, as always, send us an email. We are looking for people who have a good knowledge of astronomy, who can talk about their passion and different astronomical subjects, and who can create presentations.
It's called
various
Keynote.
topics. Sorry?
It's called Keynote on Apple.
Keynote, thank you. God, I should know that.
Yeah.
And please
I've
include a
sworn
picture of
at-
your telescope. So
Yeah.
And a picture of yourself as well.
Yeah. And your wife.
mostly telescope.
Yeah.
Or husband.
Or husband,
Yeah.
indeed. And Yeah, so thank you for that, Astromat. Yes, of course it's Keynote. The number of times I've sworn at that product, I should know it by now. So thank you for that. Yeah, Keynote,
Yes.
of course it is. So I know in Keynote you can export as a PowerPoint. So
Yes.
so that would be great. So if you'd like to join us, send us an email, and spaceoddities@gmail.com, because we would like to have more people on our Tuesday shows and more people presenting stuff. So that would be great. I'll leave that with you, dear gentle viewers.
Yeah, well, we've already got Jack said Andy, my specialist area of knowledge is spectroscopy.
Daz, you've learned how to say it finally.
Hey!
Thank you, Jack. Send us an email, spaceodditieslive@gmail.com, and we will discuss further. A spectroscopy would be a really good skill to have, actually, a really good specialist area, because, it's so important, isn't it? Right, I think we'll move on to, it's Reginald Bosanquet time. It's time for the news. So let's move on to the news. Let me just set myself up here. Okay, so just a few news items this week. The first is that Ingenuity recently made its 59th flight on Mars. It's since done a 60th, Daz tells me. But this was a record-breaking flight because it ascended to a height of 20 meters. Now, don't forget, this is the little Martian helicopter that the engineers who built it thought they would be lucky if it lasted for 5 flights. And it's now on its 59th. This is a speeded up version of that record-breaking flight, processed by Simeon Schmalb. So thank you, Simeon. And have a look at this video, because I think it's quite lovely.
Oh.
Ooh.
They were practicing hovering at different altitudes. Isn't that a lovely video?
Yep.
So well done, the Ingenuity team. Let's hope you go for another 59 or 60 flights. The achievements that little helicopter has made. Don't forget, it's not just to go up and down and look good. It's to do serious scientific work, and it's acting as a reconnaissance vehicle for the Perseverance rover, seeking out safe paths for the rover to take through this incredible landscape. Now, also, Perseverance has just ascended the ancient river delta in Gale Crater, and they had to find a safe way up, and I think they tried 6 times to get it up the slope to the top of the delta, and it failed a few times because it was so steep and the rover's wheels couldn't get a grip, but they managed to get to the top. And here's a lovely shot looking out over the top, and you can see in the background those mountains are the rim of Gale Crater, and just look at this.
That's lovely.
We're going to do a full 360 here.
Mm.
Isn't that amazing?
It is.
Certainly is.
Yep.
And
I would to be there.
Exactly.
Look at those flat areas that look like they're in.
You can definitely see where the riverbed is.
Yeah, definitely. Yeah.
What was it Buzz Aldrin said? Beautiful desolation.
Yes.
Absolutely.
Magnificent desolation.
Okay.
Yeah, magnificent. Yeah. No, he was misquoted because he loved geometry. He actually said magnificent tessellation, but there you are. Sorry, I'll get my
geometry or electric cars, one of the two.
Yeah. Okay, so that was that lovely panorama. Let's move on. Just to announce that we've started a new series here on Space Oddities called Rockets Away. Now, this is a new series of videos we're doing about spaceflight, but not just spaceflight, international spaceflight. So what we're doing in each episode is to chat about the week's spaceflight's news and pick a couple of big topics that have been in the news during the week and discuss them in some depth. And each video, we're also doing a profile of one of the world's 76 space agencies. We've done our first video and we're doing it alphabetically. So we've done a profile of the Algerian Space Agency, and you can watch all of that on the channel. How can I find it, Andy? Well, I'm glad you asked. So what you do, you go to our channel, you click on playlists and look at creative playlists, and you will see one there called Rockets Away. and our first video is in there. We would love to know what you think of it. So please, if you've got some time, I think it was about 45 minutes, wasn't it, guys? I think
Yeah,
I think so.
something
Yeah.
like that. And I was joined by Daz and Michael for the program, and we'd love to know what you think. So if you have time, I know everybody's pressed for time these days, but if you have time, and have a look and tell us what you think. Your feedback is extremely valuable. What do you like? What you didn't like? Any suggestions about it? Mail them all. spaceodditieslive@gmail.com. So that's that. And the last story this week was the fact that Blue Origin, although it's not official and definite yet, it looks like they're pulling out of the Orbital Reef space station project. And this is a major blow to the whole project. Now, Orbital Reef is a private space station, greatly encouraged by NASA. In fact, Blue Origin have taken a shed load of money off NASA for this project. NASA are trying to encourage private space stations to get the whole space station industry moving. Blue Origin have been the prime contractor with Sierra Space as the secondary contractor. And what this means for the future of the project is unclear. Why Blue Origin pulled out? Well, basically, we think it's because now that they've got the contract to build the second moon lander, they're no longer interested in spending money on Orbital Reef. That sort of makes sense. But if you do want to know more about this subject and understand it more in depth, we covered it on the first edition of Rockets Away. So again, that's just a quick plug for that. Again, that's something that we did talk about at length. And that, as they say, is the news.
Fantastic.
Oh, good.
It's been a bit of a slow news week. There hasn't been that much interesting to report this week.
Yeah.
But there we are. Now, Lou, there is one story that's really just broken about New Horizons. Can you tell us about that?
Oh, yes. Yeah, this is actually quite recent. Let's see. Can you pull it up on the screen there?
Yeah, sure. Give me 1 second and I'll do that. There we go.
Okay. So you all remember the New Horizons mission to Pluto. This was actually the second try to a mission to Pluto. The first try, Congress said no, too much money. And the scientists screamed and said, we're worried that whatever atmosphere is there as Pluto moves away from the sun will collapse on the ground and it'll be terrible. So they built New Horizons. And they launched it back in 2006. Here, let's get a... Oh, no, don't do it that way. Do it this way.
Is it moving? There we are.
There we go. Launched in 2006 with Pluto Encounter 2017. And then it went on to encounter Ultima Thule, which is now not called Ultima Thule. It's called
Amarok.
Yes, yes. So very successful mission. Our first look at Pluto and the Pluto system, its moons, its atmosphere, its fields and particles, and on to the Kuiper Belt, where it imaged pretty high resolution Kuiper Belt object. And so now what? Well, that's the original mission, and they were hoping to get a new mission funded. New Horizons is now safely in the Kuiper Belt at about 57 AU, and speeding out at, let's see, it's 2 or 3 AU per year, I think, in either event. So now what's to be done? So the New Horizons team requested a 5-year extended mission. And there is some thought about this. And the thought is, well, why should we extend the mission? The average distance between Kuiper Belt objects is something like 1 million kilometers. They have no targets in sight right now. It's kind of a needle in a haystack type thing. Could you possibly, at the 1% level or less, meet up with a new object that you could explore? But they resolved this in a very clever way. let me move forward here. Okay, so there's New Horizons moving away from the sun in the Kuiper Belt. And their resolution was to say, well, maybe you'll have be able to do some planetary science, maybe not. In the Kuiper Belt, there's other planetary science you can do. You can look back at Uranus and Neptune, for example, and see the scattered light that only you can see when you're on the other side of those planets. You can't see that from Earth. So there is some science to be done there, but there's also science to be done to measure and analyze the heliosphere, the solar wind, out at that distance. And so here we have Nikki Fox, who is the new head of NASA SMD, the Science Mission Directorate. And that encompasses all of space and Earth science, including heliophysics, astrophysics, planetary science, Earth science. And she says the New Horizons mission has a unique position in our solar system to answer important questions about the heliosphere and provide extraordinary opportunities for multidisciplinary science for NASA. So they're going to continue the mission for till about 2028, 2029, which is the estimate of when it would exit the Kuiper Belt, if there is, in fact, an edge to the Kuiper Belt, and I don't know the answer to that. But in the meantime, it's going to have both planetary and heliophysics science. And so I think it still sits firmly in the planetary science funding channel, but heliophysics is going to help manage and select observations. So good news for the New Horizons team, good news for Alan Stern and his group, and hopefully we'll get some good science out of this.
It's very good news indeed when you think about it, because, personally, well, not just personally, I mean, everybody thinks this, that to successfully put a spacecraft into the Kuiper Belt, when there is so much to be discovered about the Kuiper Belt, and then just to say, no, you're not going to do that anymore, you're going to do something else, made no sense to a lot of people. And
when you spend the millions of dollars that it takes to design and test and launch something like this, it's always good to give some real thought to extending the mission to see if there's some new science that can be done.
Because it's not beyond the realms of possibility that another object could be discovered in the Kuiper Belt that New Horizons can visit with its current trajectory. It could happen,
And at minimum fuel expenditure, I think.
Exactly.
Exactly. But all the people involved with the mission as well, through the design stages and the implementation. Everything else.
That's right.
So,
yes. So there we are. So thank you very much.
Because also, isn't it carrying the ashes? Some of the ashes of Clyde Tombaugh, if I remember rightly.
I think that's right. Seem to remember something like that.
Yeah, they put some of his ashes on there out of respect. So that was good.
He's screaming now. He said, "Wait, you've gone too far."
yeah.
Turn around.
Yeah, absolutely.
Eject.
Yeah. Yeah. So he would be happy that the mission was carrying on like that. So, So there we are. Okay, one thing that we've been leading up to on Space Oddities over the last couple of weeks has been the launch of the Psyche mission. Now, by sheer serendipity, they discovered with a week to go before the launch that there was a problem with the gas thrusters, that they were not running to the correct parameters. As the spacecraft has a table of data about how the gas canisters, the gas thrusters perform, and it was wrong data. So they've had to reprogram the computer with the right data for the gas thrusters, because if they had used existing data, the gas thrusters would have got far too hot and it could have damaged the spacecraft. So this is a way of saying that the launch has been postponed until the 12th of October, when we hope to cover it here on Space Oddities. But nonetheless, we thought you might like to know a little bit about the mission. And our trusty Psyche reporter, that's Psyche, not Psycho, of course, he has been delving into the incredible, beautiful Psyche mission, which promises to deliver so much. So Michael is going to tell us about the Psyche mission, I hope.
Yes, I certainly am. So I'm going to share my screen in a minute.
I've got it up on the screen.
You have, but I need to play a couple of videos, so I'll, yeah, I can play them from here probably.
Okay, should we come back to you?
Yeah, come back to me in a few minutes. I'll get my presentation
Okay,
ready properly.
all right.
Yeah,
in the meantime,
sorry
then,
about that.
Michael's having a few technical issues. So we will go to somebody else who's just busting to tell you about something amazing. And that is young Daz, of course. So, Daz, what are you going to tell us about tonight?
My Veruca. I did promise you. No, I did say I'd have images. Well, basically, when Andy was talking about possibly new members joining us and producing content for us as well, he showed an image of how to find our new show. You notice that the poster next to it was for astronomy basics. Now, this is one of the astronomy basics. Now, normally what they are, there's usually sort of like 10, 5, 10, 15 minutes long, maybe 20 if you wish. And it's a PowerPoint presentation. And what we do is we just pop them up. They're really, and as we said, they are basic. They really are basic. So we try to we're looking at the beginners to try and bring them on, because we sometimes get people come and email us because they're a bit shy to come on air. But yeah, so basically this one is about classifying stars. Now, normally this would be narrated, and I have done a narration one, but we find that for some unknown reason, when we play the narrated PowerPoints, we don't get the sound from them for some unknown reason. So okay then, so we'll start from here. Right, I hope you can see that on the thing.
Yeah, indeed.
Right. Now, our sun is a star, and it's very precious to us, this star. But where does it truly sit in the pantheon of stars? As we know, the life cycle of a star begins with its formation from a cloud of gas and dust. The star then evolves through a series of stages depending upon its mass. Stars are classified by their spectral type, which is determined by their surface temperature. The spectral type is a letter from O to M, with O being the hottest and M being the coolest. So I mentioned the spectral type. So to classify the star spectrum, and Jack, hope you're listening, astronomers use a spectroscope, which is an instrument that splits light into its component wavelengths. The resulting spectrum is then compared to a series of reference spectra of known stars. By identifying the absorption lines in the spectrum, astronomers can determine the elements present in the star's atmosphere and so get its temperature. Below the writing here, you've got a spectrum of just normal light. It's the rainbow that everybody knows. But at the bottom, you see another spectrum, but this time it includes the absorption lines. Now, these lines we don't usually see in normal light, but through a spectroscope, we see these lines appear. And these lines are the elements that actually are sitting in the atmosphere of the star, and they appear in the spectrum. By studying these, we know the wavelengths that these lines should appear. So we know what elements are what, and also by studying how strong they are, we can gauge how much there is actually in the atmosphere. And from that, we can actually get the temperature of the star. So here are the different spectral types. On the right, you've got the Hertzsprung-Russell diagram. Now, this diagram appears for virtually anything to do with stars. It tells the story from a star's birth to its death, and it shows you the routes different routes it takes. But if you look along the bottom, you can see the spectral type letters and their corresponding temperatures. And on the right, you can see a table of the actual what temperatures each number goes from. So, excuse me, here we go. Now, as you can see on this image on the left, this is a deep field image, and you've got on there all the different colors of the stars that we've got. We've got some nice orange ones, there's some yellow ones, there's blue ones, there's white ones, and again on the right hand side I have a table which again gives you all the spectral. In column 1 it gives you the spectral type. In column 2 it gives you the sun sizes, the star sizes in masses, in sun masses. With basically it just shows the difference in size from our actual sun, and our sun actually being one sun mass. The third column we have the temperature which they're associated with. We've also then in the fourth column got the colors that's associated with these classes, and then in the final column you've got famous stars which are associated with each class. In addition to their spectral type, stars are also classified by their mass. The mass of a star determines its lifespan. More massive stars have shorter lifespans than less massive stars. Eventually, the star will die and become a white dwarf, neutron star, or a black hole. The least massive stars are called M stars. They are very long. They have very long lifespans over billions of years. The Sun is a G-type star. It has a surface temperature of about 5,800 Kelvin and is a medium mass star. The most massive stars are called O stars. They have very short lifespans, only a few million years. In this diagram, you can actually see a comparison of different stars that we all know in the night sky. The Sun is hardly discernible. It's 1 pixel in size. And then you've got Sirius, Pollux, Arcturus, Rigel, Betelgeuse, and then you've got Antares. I mean, look at the size of Antares compared to the Sun, and that's not the biggest star.
No. XY Scooty is still the biggest as far as I know.
Yeah, that's right, yeah.
Yeah.
Now, this pictograph actually depicts the life and death of stars depending upon their size. They all start as a protostar, of course, in their star nurseries. They go through their evolutions, but they've all got different deaths, ranging from turning into white dwarfs, which is the fate of the Sun, to neutron stars, and also to black holes. The bigger the star, there's a bigger chance that it will actually go straight to a black hole, even avoiding the actual supernova stage. It would just collapse into a black hole. So the conclusion: the different types of stars are classified by their spectral type and mass. The spectral type determines the star's surface temperature and color, while the mass determines its lifespan. While the mass determines its lifespan. By understanding the different types of stars, we can learn more about the formation and evolution of galaxies.
Fantastic.
Spectral classification is a powerful tool for learning about stars. It can be used to determine a star's temperature, composition, and luminosity. This information can then be used to learn about the star's history, its future, and its place in the universe. So as Goldilocks would say, this star is too hot, or this star is too cold, but this star is just right. Luckily, this star is our Sun, plain old Mr. Average in the scheme of things. But all said and done, too hot or too cold, we would not be here. So that's the sort of thing we're looking for.
Yeah, very true. Very good, Daz. Thank you very much.
That's right.
So, yes, very interesting. And, spectroscopy is so important to all astronomy these days. And spectroscopes just keep getting, or spectrographs just keep getting better and better and better. I was watching a documentary about the ones at the VLT in Chile, and the technology is absolutely mind blowing. So yes, there you are, spectral types of stars, very very
Exactly.
important.
I mean, we're using spectrographs and also using the Herschel. I've done it again.
Yeah, you
Hersprung, Hersprung, Hersprung technique.
yeah, yeah.
The graph. They actually can also use these to study. They look at groups of stars like and closed star globulars, and
Yeah.
they also look at galaxies, and they can use the spectrographs also to discern the age of these globules and clusters and things like that. So it's an exciting tool. It really is.
Absolutely, absolutely. So thank you for that, Daz. Michael, have you got your technical?
Yeah, I can try it. I'm not sure about the sound from the video, but I'll try it now anyway. So
Okay, it'd be interesting to see what happens there. Actually.
yeah, just bear with me a second. I will share my PowerPoint.
Yep.
That one. Okay, and there we go. Can you see that?
Yeah.
Got my.
Let me just have a look. Sorry, I've just right. Yes, we can. I believe it's this one.
Right.
There you are.
Okay. Well, evening, everybody. I want to talk to you tonight about the Psyche mission, or the Psyche mission.
No, definitely Psyche. Definitely.
Psyche. Okay.
Let's agree on that.
Yeah, I've heard you pronounce it a few times differently. So I just want to talk to you about the mission and the history behind this tonight. So just bear with me. Yep. As it says, mission to a metal world. I'll come onto that in a minute. That's just an illustration showing what the mission is all about. Okay, the Psyche mission is a Discovery-class mission to study a metal-rich asteroid located in the main asteroid belt between Mars and Jupiter. The Discovery program was founded in 1990 to implement the policy of the then NASA Administrator Daniel S. Goldin. I'm sure some of you all remember.
The infamous Daniel F. Goldin. Yes, we remember him well.
The program was to build faster, better, and cheaper planetary science missions.
And it was a disaster.
Yeah. And Discovery missions are solicited through a call for proposals on any science topic and assessed through a peer review. Also led by a scientist called the principal investigator. So I'll go on from there. Yeah. Just another graphic saying what the mission is all about. I picked up the first time ever. We are exploring a world made not of rock or ice, but of metal. Okay, so this is an introduction to 16 Psyche, the actual asteroid itself. 16 because it was the 16th asteroid discovered in the asteroid belt. So deep within rocky terrestrial planets, including Earth, scientists infer the presence of metallic cores. What makes the asteroid Psyche unique is that it appears to be the exposed nickel-iron core of an early planet, one of the building blocks of our solar system. Because we cannot see or measure the Earth's core directly, Psyche offers a unique window into the violent history of collisions and accretion that created the terrestrial planets. Just want to go through a little bit of history again, go back a bit further. The asteroid belt between Mars and Jupiter, there is quite a big space between the distance of Mars from the Sun and the distance of Jupiter. And in 1766, the astronomer Johann Daniel Titius of Wittenberg, Germany, noticed an apparent pattern in the layout of the planets, now known as the Titius-Bode law. And it states that if one began a numerical sequence at 0 and then included 3, 6, 12, 24, 48, etc., doubling each time, and added a 4 to each number and divided by 10, This produced a remarkably close approximation up to the radii of the orbits of the known planets as measured in astronomical units. Just an example of that here. You got Mercury 0.39 astronomical units, Venus 0.72, Earth obviously 1, Mars 1.52, Jupiter and then jumps up to 5 astronomical units. So you can see there's quite a big gap between Mars and Jupiter in the distribution of the planets there. Okay, so provided one allowed for a missing planet equivalent to 24 in the sequence between the orbits of Mars 12 and Jupiter 48, Titius declared, but should the Lord Architect have left that space empty? And the answer is not at all. When Herschel discovered Uranus in 1781, the planet's orbit matched the law almost perfectly, leading some astronomers to conclude that a planet had to lie between the orbits of Mars and Jupiter. Bode's law was widely accepted until 1846, when Neptune was discovered in a location that does not conform to the law. Simultaneously, due to the large number of asteroids discovered in the belt, Ceres was no longer a major planet. In 1898, the astronomer and logician Pierce used Bode's law as an example of fallacious reasoning. So just an example, this is Ceres, discovered on 1st of January 1801 by Giuseppe Piazzi from an observatory in Sicily. As I said, Ceres was later classified as an asteroid, but then more recently, Ceres was declassified to a dwarf planet, and it's the only dwarf planet that lies always inside Neptune's orbit. And just an example of other dwarf planets, you've got Vesta, Eros, which is the small dot on the screen there, Ceres, Charon, and of course, unfortunately, Pluto. And this is just a diagram showing the asteroid belts between Mars and Jupiter. Where you've got inner planets there. This is the main belt of the asteroids. Then you've also got outlying asteroids in Jupiter's orbit. You've got the Trojans and the Greeks, which are the Lagrangian points of Jupiter's orbit, and also another sort called the Hildas. Okay, so this is a artist impression or rendering of what we think Psyche 16 Psyche actually looks like. You can see it's quite rocky, quite bold, a lot of boulders, and 2 big depressions towards the centre of that particular area of Psyche. And that image was actually created by radar and images from the ground. You know what they could infer from those radar images. And in 2019, the Very Large Telescope Adaptive Optics System photographed 16 Psyche, and you can see that optically from the ground, not much detail at all, really. Okay, so just going on to the spacecraft now. It's when the solar panels are deployed, it's going to be 81 feet in diameter, or 25 meters, by 24 feet wide. Psyche would just about cover a tennis court. The bus is 16.1 feet, or the body of the spacecraft, tall, including the 6.6 foot booms for 2 instruments. The spacecraft mass at launch is expected to have up to 6,000 pounds, or 2.7 kilograms, 1,000 kilograms, including the deep space optical communications technology demonstration, which I'll come on to in a minute as well. The power is provided by 2 5-panel cross-shaped solar arrays to power everything on board, including the science instruments. And this is a picture of the spacecraft in one of the clean rooms during one of the inspections, and you just see the size of it compared with the humans there for scale. It's quite a big spacecraft, really. So that's the size of it. This is an artist's rendering of what it would look like, as an asteroid with the solar panels unfolded. Right, there's a couple of items of technology that I want to discuss. Psyche, the first is the propulsion side. Psyche uses solar electric propulsion. The spacecraft has 4 Hall effect thrusters that use electromagnetic fields to expel charged atoms or ions of inert xenon gas that in turn create thrust, trailing a blue glow of xenon. Only one thruster is used at a time, providing up to 240 millinewtons of thrust. This particular system is very efficient as compared with liquid-fueled rockets, and but it's one reason why the spacecraft is taking such a long time to reach its destination. But the technology has been used before, but it's one of the things about the Discovery program that they want to use the technology. And the other technology is data communication. Psyche will use NASA's Deep Space Optical Communications Experiment, or DSOC, using a near-infrared laser. DSOC will be the agency's first test of high-bandwidth optical communications between Earth distances as far exceeding the Moon. Now, one thing about that is, although it's a high bandwidth, the communications it won't actually speed up the actual communications. It'll just it will allow a lot more data to be transmitted through the system at a time. Okay, and the other one is the I think what we're all looking forward to is the multispectral imager. This consists of a pair of identical cameras equipped with filters and telescopic lenses to photograph the surface of the asteroid. Cameras can take pictures in the part of the spectrum visible to the human eye, as well as near infrared wavelengths. Okay, I was going to try to play this video just to see if the sound works. Can you hear that?
No.
Okay. Okay, I won't play that now. Then I shall. Don't know why that would be then. Okay, we'll have to sort something out for that at later days.
Yeah.
Okay, I'll go to the next slide. Oh, hang on. No, how do I get to the next slide? Oh, there it is. Right, this is a diagram of the spacecraft showing the different components. And, so 81 foot wingspan, 24.7 meters. Okay. And again, this is another.
They're huge.
Yeah, the solar panels, and that's only the part of them, of course, because it's got the other panels above and below.
Yeah.
That to fold out as well. Yeah.
Gosh.
And again. And forget that one as well. Okay. Now, the launch itself is going to be conducted on a Falcon Heavy launcher. So that will be something that's a good launch to watch. Falcons have been generally used to do communication satellites and various other satellites like that. only in the recent years they've actually started doing planetary missions. So just one thing about this particular mission, the side rockets will be recovered on the 2 landing zones on land this time. They were previously used on the commercial communication satellite. And they'll be recovered again on the landing zones after this particular mission, and will be used again on the Europa Clipper mission in October 2024. So it's another one to look forward to.
Yeah.
This is the actual flight through the solar system for Psyche. Launch October 2023. It'll have a Mars gravity assist in May 2026. And then the arrival at Psyche will be August 2029. And initial orbital operations are at the moment up till November 2031. And it will actually use 4 different orbits at various altitudes to observe the asteroid imaging and other observations before the end of the mission. Okay, that's it.
Thank you very much, Michael. That's wonderful.
Okay.
Yeah.
And yes, I mean, this is a very important mission because at the end of the day, we're really not sure about the origins of Psyche. It's assumed that it's an iron nickel core of a planetoid dating from the birth of the solar system or shortly thereafterwards, but we really don't know. And it's been estimated that if all the measurements are true, it seems to be made of metals, including lots of precious metals like gold and silver and platinum, whose total value exceeds that of the whole global economy. Several quadrillion dollars, wasn't it, Dad?
Yeah, about $8 or $9 quadrillion, which would
quadrillion dollars.
yeah, that's a lot of noughts after an 8.
Yeah. Lou, did you want to say anything about the mission?
Well, not about the mission so much. Great presentation, Michael. Loved it.
Thank you.
But about the structure and evolution of the solar system. So Neptune doesn't fit into this Titius Bode model.
Yeah.
But there is some pretty strong evidence from computer models now that the solar system that we see today is not the solar system that was. And we got turned on to thinking about this in part because as we look out beyond our solar system to other stellar systems, we see a lot of hot Jupiters, Jupiter-sized planets orbiting within what would be the orbit of Mercury in our solar system.
Mm-hmm.
So if you look at that, you start thinking, well, why don't we have a hot Jupiter? In addition, as you track the densities of the planets, they kind of go down, and Uranus and Neptune then go up. And why is that? And the thinking is that Uranus and Neptune actually formed much further in, much closer to the orbit of Jupiter, and that Jupiter and Saturn migrated inwards toward the sun. And kind of slung
Slugged.
to Neptune and Uranus out to their current positions, and that as Saturn and Jupiter migrated inward, Saturn actually pulled Jupiter back. Saturn's gravity pulled Jupiter back to where we see them today. So our lifetimes are short, so we see the universe and the solar system as it is for maybe 100 years, but that appears to not be the case over many billions of years.
Yeah.
Interesting.
Okay.
Interesting.
Yeah, because one of the things that you did see is when you showed the slide, they've sort of like modeled what they think the surface of 16 Psyche looks like. And it's where you've got the not so much the big craters, but on the smaller craters, they think because it is metallic, that when it's been hit, the molten metal is actually shot up, forming the crater, and at the top of the crater, because it froze so quickly because of the coldness of space, that the actual tops of the craters look like crowns with spikes then on there.
Yeah.
But also on the actual surface, they think there's round globulars of metal just sat there waiting to be picked
It's
up.
one of the things on the video I wanted to show is a very nice animation that's where an object collided with Psyche and tore off the upper layers of the asteroid to reveal the core. So that's how it actually became a core rather than a full planet.
And you were talking about the optical communication system. The idea behind that is as you said, it's got massive solar panels because it's so far out. It needs them.
Oh yeah.
And also to drive the engines. And I think the first time I can remember ion engines, me personally, somebody will be able to correct me on that, was on Dawn to Ceres.
Yes, that sounds about right. Yeah,
that's right.
And at the time, I mean, I think the acceleration rate on there, 0 to 60, was about 5 days. But once it got itself wound up, at the time, it was one of the fastest probes. It was the fastest probe, man-made probe in space at the time to get to Ceres. But and also when you were talking about the optical communications, and again, as I say, go back to the solar panels, it takes a lot of power to power a radio signal. So they're looking at the lasers because they can actually put far more information into a laser beam for exactly the same amount of power. So it's basically they'll be able to transmit far more data at a fast speed, so it'll cut down the time lag.
Yeah, and of course the solar panels, like everything else, they're a lot more efficient now, but they still need to have those large solar panels to actually power the whole thing. Yeah,
absolutely.
But one of the main things, and we were talking about this the other day, was that for the laser to work, the actual transmitting laser, if you want to call it that, will actually detach from the probe, although it'll be sat in a cage because they don't want it floating away, and it will have a tether because it's got to be powered and things like that. But it will actually be free floating in space, and while that's actually happening, the probe itself will not be able to do anything. It'll have to be sat there dead in space while it does this transmission. Because it's got to, because of course a laser, it doesn't take much for it to drift. So this thing will be floating, and then what it'll do is then it'll reattach itself back to the probe when it's not being used. It's the technology that's gone into this whole thing is fascinating. The new technologies and the new methods they're going to be using is amazing. Can't wait for it. Can't wait.
I think we can put a link to the videos in the description, can't we, Andy?
Absolutely. Yeah, just send me the details and I'll put them in the description.
Okay.
Yeah. All right then. So thank you very much for that, Michael. It promises to be an incredibly interesting mission. And we do stand to learn a lot about the early history of the solar system, including the things that Lou was talking about. So there will be a lot of, if the mission is successful, which obviously we hope it will be, there'll be a lot of great science, I'm sure, to come out of this mission. And you'd think by now we would have a very, very good idea of what the history of our solar system is, but really there are a lot of areas and things we just don't know, because after all, after 4.5 billion years, there's not a lot of evidence around of the exactly what happened in the early formative period of the solar system. So
I'd just like to say something else as well. When the spacecraft gets to Mars and has its gravity assist, I'm wondering whether any of the rovers on the surface may be able to see with their cameras.
Maybe. Yeah, that would be good, wouldn't it?
It would, yeah.
Those big solar panels, perhaps.
Yeah, absolutely.
Yeah.
So there we are. Okay, well, just a couple of things before we finish for the evening. Don't forget, inevitably, absolutely 100% inevitably, winter is drawing on. That's one thing we can absolutely depend on, although the winters that we're having, of course, are thanks to climate change changing in nature. Of course, we've got an El Nino as well coming up, so who knows what this winter is going to be like. But almost certainly the temperature is going to drop. And here in Spain, it's still about 29, 30 degrees during the day. But next week and the week after, we've been promised unseasonably cold temperatures with snow in parts of Spain. So, it's a bit weird, really. But what I'm trying to say is you really need something to protect you in these cooler temperatures. So why not treat yourself to a Space Oddities hoodie? And you can buy one for the wonderful sum of £35, including postage and packing in the UK. Please add £10 for foreign orders. And you can scan the code here if you would like to buy yourself a hoodie. Or, of course, I'm sorry to mention it again, the dreaded C word. Santa Claus is coming, and they make fantastic presents. So buy somebody who would appreciate it, even if they don't. Buy them a Space Oddity hoodie, and they can be the first person on their block to own one, and they'll be very cool wearing them as well. The hoodies come in one of 9 colors, and they come in 2 designs: the pullover one, which has the design on the front, and the zipper version, which has the design on the back. But you really ought to be thinking of what you're going to be doing next summer. So, because you really need to start thinking now about buying yourself a new T-shirt for next summer, and that would be a Space Oddities T-shirt, funnily enough, at the again, yes, as modelled by the pouting lovely Roger here. Thank you, pout for me, lovey, and they are for the amazing price of £19, again, including postage and packing in the UK. Please add £10 of foreign orders. You can scan the code now, or you can follow the link that is in the description of this video. So there we are. That's the merchandise out of the way. We would, of course, like to thank all of you who continue to buy us coffees. It's much appreciated. It all goes into the coffers to keep the boat afloat, as it were. And just to reiterate, because I know we had a couple of latecomers tonight, we are looking for people to join us on a regular basis on the Space Oddities panel. You need a broad knowledge of astronomy and space flight and what's going on. And also, if you have any speciality subjects that you love telling people about, then that would be great too. You must be able to create PowerPoint presentations or Apple Keynote presentations, which then export to PowerPoint, because we can only handle PowerPoint presentations. So if you fit that bill, if you would like to join us here on the panel on Space Oddities, we'd like to hear from you. Send an email to spaceodditieslive@gmail.com as ever, and we shall look forward to hearing from you. And thank you very much for your interest. And I think that just about wrapped things up for this evening, does it not, guys? Unless anybody's
I just mention, remember on September the 6th, we saw the Japanese launch CRISM, the X-ray telescope,
yes,
along with the lander SLIM.
yes.
Well, SLIM has now actually left Earth orbit. It left on the 30th of September.
Hurrah!
It's on its way to the moon, and it should arrive tomorrow. Have its first encounters tomorrow. So
brilliant.
Yeah, so hopefully we might be seeing very soon a new lander on the moon. And of course, this is using facial recognition technology, because it's sort of like subtitle is Sniper, Lunar Sniper, because they're actually going to try and land it within a few hundred meters of an actual target crater. And what they're doing is they've had a orbiter photograph in the lunar surface. They've inputted all the information into this little gimmicky thing using facial recognition, and it's gonna look at the surface as it comes down and recognize exactly where it is and pinpoint its landing. That's the theory. But fingers crossed for them. We hope that's all.
Slim.
Yeah, that's awesome. There.
And can I just sorry, that's you.
Yeah, carry on.
Oh, sorry. I was just going to say, on the back of what Michael was telling us about Psyche, we are going to try and cover the launch live on Thursday, the 12th of October. And unfortunately, I won't be available. But I think Michael and Daz, you're hoping to.
Yeah, we're hoping to be able to get it all
Yeah.
Okay,
sorted.
so
Yeah.
keep your eye on the channel. Have a look at the channel. We have more than 160 videos on the channel now in various playlists that we've created. Do go and have a look. Don't forget our latest series of videos, Rockets Away, in which we talk about international space flight in a bit more detail than we have time for in this program. And each week each video, we're not quite sure how often we'll be doing the videos, but each video we will be profiling one of the world's 76 national space agencies. And the first video, which is in the playlist called Rockets Away, is about the Algerian Space Agency. And the next one we tackle is Argentina. So you've got that to look forward to. And we'll work our way slowly through the alphabet and tell you what each country is doing in space, what the plans are. And there we are. So check out Rockets Away if you get time, and give us your feedback. spaceodditieslive@gmail.com as always. I'd like to say a big thank you to you for watching, viewers. Very kind of you to be with us on this Tuesday evening. We do appreciate you spending the time with us rather than anywhere else. And I'd like to say a big thank you to Michael, to Roger, to Daz, and to Lou for joining me this evening here on Space Oddities. Say goodbye, guys.
Goodbye,
Good
guys.
night.
Guys.
We'll be back, of course, next Tuesday, same time. Keep your eye on the channel, which will tell you when we're on, of course. Don't forget to like and subscribe, and turn the notifications on so that you get notified of when we're going live, and have a wander through our other videos. All right, then. Thanks to all of you for watching. We will see you again next week from all of us here at Space Oddities. Have a wonderful week. Be good. And if you can't be good, be average. And we'll see you again next week. So from all of us, bye-bye.
Keep looking up.
Keep
Bye.
looking up.